This is reviewing graphing with trig functions, part 5. Today we're going to focus on tangent. So just to review, when you have sine or cosine, these are the basic functions, and then sine starts in the middle compared to cosine, which starts at the top. And then if you have a negative in front, it's going to, of course, flip it upside down. The amplitude is just the absolute value of the number that's in front. The period is always 2 pi divided by the b value. The mean line is just y equals this number, the k. And then phase shift, you can either set the inside equal to 0, or you can view it as c divided by b, which is the same thing. Then what we're going to do is expand that over to tangent. So tangent looks like this. It has vertical asymptotes. The amplitude was defined as half of the height between the maximum and the minimum. Well, the maximum is infinity and the minimum is negative infinity, so the amplitude's undefined. The period is different. So the amplitude changes to undefined always. The period is now pi over b instead of 2 pi over b. The phase shift doesn't change and the mean line doesn't change, but now I also have these vertical asymptotes. And if you think about it before a phase shift, you can always find it by just taking the period and dividing it by 2, and then adding the period times a k value. Now k is just an integer. Okay. So basically, if we look at values from the unit circle, you can look at how to get this parent function. But what I want you to focus on is the fact that at 0, it has a dot. And then at pi, which is the period, it has a dot. And halfway between that is an asymptote. So this would be considered one period. Okay. So go ahead and pause the video, copy that down, and then we're just going to do some examples. So for here, oops, can't see that. There we go. We're going to, first I'm going to show you what the a value does, because the amplitude is undefined, but that is going to still stretch the graph. And then we also have, let's do the period next. So the period is always pi divided by the b value, and in this case the b value is 1. Okay, and then the mean line is going to be, we're moving this whole thing up 2. And then the phase shift. C in this case is 0. So if we look here, we can do the c value divided by the b value. So you can either think of it as 0 over that b value, which is 1. Or you can just think about it as setting it equal to 0. You get the same thing. Okay. We'll talk about the vertical asymptotes in a second. But basically what this is doing is I'm going to take the period. I'm actually going to take twice that. Okay. This is going to be shifted up 2. Oops. Okay, there we go. So I'm going to shift this whole thing up 2. So now this is that middle line. And then I'm going going to go 1, 2, 3 above that, 1, 2, 3 below that, but that is not a maximum and minimum. What's happening is I'm going to have a dot at this at x is 0 and at the period and any multiples, so 2 pi, negative pi, and then halfway between that is going to be where I have vertical asymptotes. So in this case it's at pi halves and 3 pi halves and multiples of those that don't reduce down. Okay. Now where this 3 comes in is if I go halfway between the dot and the asymptote, it's going to be 3 above the midline and 3 below on the other side. Now when graphing these by hand, I don't actually care that you show that. So I just go like that. Then we get the general idea. If you want that level of precision, use a graphing calculator or a computer or something. So tangent is an increasing function, and that's what it's going to look like. Now there were no phase shifts, so I do want to talk about the vertical asymptotes. It's always going to be without a phase shift. The period, which is pi, divided by 2, because we are taking that period and cutting it in half, and then we're adding that repetition. It's going to repeat every period, which is pi times k. So if I were to actually work through this, that would mean that if k is 0, the baby's waking up, I would just get pi halves. If k is 1, I get 3 pi halves. If k is negative 1, I'm really subtracting, I'm going to get negative pi halves, which is where these 3 are. So this allows us to, I can go farther, I can do 2, 3, 4. This allows us to represent the vertical asymptotes. So the way I write domain and range is all real numbers such that x is not equal to a vertical asymptote. And the range is just all real numbers. Okay, I'm going to pause the video and then go get my baby. Okay, you might hear Sesame Street in the background, and baby screams, and baby toys. Okay, so again, I'm going to kind of work through this information on both of these. The amplitude is undefined. On both of these, the mean line is actually 0 because we're not adding anything or subtracting anything to the function as a whole. So you could view it as adding 0. Okay, and then the period is pi divided by the b value. And this one, the b value is 1. So we get pi. This one, the b value is 1/3. So what ends up happening is I multiply by the reciprocal and I get 3 pi. Okay, and then the phase shift so either view it as the opposite sign of this divided by the b value, which is going to be negative pi fourths divided by 1, which is just negative pi fourths, or do x plus pi fourths, set that entire thing equal to 0 and solve. Either way you get negative pi fourths. So we're moving backwards pi fourths. On this one, We aren't adding or subtracting anything to that x, so there really isn't a phase shift. So you could put 0 or that there isn't one. Okay, so to graph this, we're going to, I don't know, just list out 2 pi, pi, negative pi. I'm picking these values just because it's habit. So that's pi halves, negative pi halves, 3 pi halves. Because we're going to be moving by fourths, I'm going to make fourth marks. Okay, so tangent starts at 0 and at the period is back at 0. Except we need to move this back pi fourths. So I'm going to say instead of at 0, it's at negative pi fourths. Instead of pi, it's at 3 pi fourths. Okay, and then halfway between that is where we have an asymptote. So if I count, I'm going in 1, and then right here is the middle. Right there. And then I just kind of go off of that. So 1, 2, I had a dash. 1, 2, I have a dot. 1, 2, we have a dash. 1, 2, we have a dot. And going backwards, 1, 2, we have a dash. Okay, and then this is tangent, and that's an increasing function. So it does something like this. Okay, and the domain is all real numbers except where we have vertical asymptotes. The range is all real numbers. Now, if I want to figure out what the vertical asymptotes are, this isn't going to work the same way as before, because if I take half the period, that's pi halves, that's not where I have an asymptote. So I have to actually think about shifting that as well. So pi halves minus pi fourths gives me pi fourths. And then the rest of it is still the same. Now, if you're getting stuck on this part, I'm not going to ask you this on the test, so don't stress about it. Okay, and then this last one. So because the period's going to be 3 pi, I need to make sure I include 3 pi as well. So the mean line is still 0, and there's no phase shift, so at 0 and the period is where it has dots, and then halfway between that is where it has the asymptote. But halfway between I don't have a mark. That's okay. I can just put it there. And then it's an increasing function. So I'm not getting a whole lot on there, but that's still what it's doing. So all real numbers such that x is not a vertical asymptote. All real numbers for the range, and my vertical asymptotes are 3 pi halves, because you take that and cut it in half, and then plus the period. Okay. I have 3 more examples for tangent, and then we'll be done with the majority of the graphing.